Welcome to Programming Rainbow. In this video, we will be starting a new series. This will be Conway's Game of Life written in C and SDL2. So if you want to follow along with this video, you can go to github.com, Programming Rainbow, Conway's Game of Life, C, SDL2. You can clone that repository, move inside the directory, open it up with whatever editor or coding thing that you want to use, and you can follow along. So the whole project is already done. You can compile what's in the source directory, but you can also look what is in each individual video. Okay, and there's some instructions down here. I'm on Arch Linux, by the way, so these instructions will be based on that, but this should work in other systems. This has been tested on Mac, and it should be fine in other Linux systems too. If you're on Windows, you should think about not being on Windows. Okay, so let's show the project real quick. This is just going to be the final project running. Okay, so what we have here, Conway's Game of Life, let me just pause it. Basically, there are rules if a cell is alive, like it's white here or gray. If a dead cell has exactly 3 living neighbors, it becomes alive in the next generation. So if a cell is not, so basically these cells, the lit ones are alive, the black ones are not alive. So if you have a black one that is touching, there's 3 other live ones around it, it becomes alive in the next generation. If you have a living cell that has 2 or 3 living neighbors, it remains alive the next generation. In all other cases, the cell dies. It's actually written as like 4 rules, but I've condensed it to 3 that mean the same thing. So what happens here is based on whatever cells are around it, each generation, if I slow it way down here, so this shape here is stable, it never changes. But if I were to click right here where my mouse is and add a cell, like I'll even pause it and click there. Now you see that I've added one. This is no good because this cell is touching more than 2 or 3 other cells. So it's going to die. And these other cells are going to do other things. Like this cell over here is going to come alive. This cell over here is going to come alive. So if we unpause it here, this is going to start changing shape and doing things now. And you can have all these interesting shapes. You can make gliders and everything else, things that look like spaceships that move across the screen. And you can actually create very complex things where you can create emitters, things that send out signals. You can create gates, and you can actually create this entire game of life or computers inside game of life. So with just the simple logic of the 3 rules of what is going to be alive or dead in the next generation, you can create a computer inside of here, which could be playing a clock or playing the game of life itself. So if you look it up, it gets pretty interesting. This is a very simple idea, but it can be taken to extremes. So anyway, you can do whatever you want with this. I'm just kind of showing it off here. I'm going to speed it up. There's some speed controls. We can make it run really fast. Let's see, slow it down a little bit. We can see a glider sometimes. Where's a glider? Okay, right here, this guy right here is a glider. I'm going to get rid of these so it doesn't impact them, so it just keeps moving. And this glider, I'll slow it down a little bit. This glider is going to keep moving. See, this shape keeps moving. And you can actually have another shape that emits these gliders. And you can have another one that actually reacts differently depending on how a glider hits it. It could emit another glider. You can make very complex things. This shape right here keeps changing, but it's kind of stable. It only goes between 2 states. But when this glider interacts with it, it's going to change what happened. Anyway, that's enough of that. So in this video, we are going to be setting up the basic structure. We're going to be creating the game object, and I call it an object. It's basically the struct on the heap and the functions that work with the struct. So it's a little bit like object oriented in idea, but it definitely C style. So we're going to be setting that up, and we're going to be opening a window with the render, everything else. That's what we're going to be doing in this video. We have these, the source directory. This is what we're going to be working in. And then these are the the finished code for each video. So if you want to see the code at the end of this video, it'll be in here, which will just have these files right here. And so in each directory, there is the code. So the 6th directory is actually the final code, which is the exact same as what's in the source directory. So we're going to delete this source directory and we're going to start building this up. So we don't need this anymore. I'm going to close this as well. So I'm just going to delete the source directory. That's the simplest way for me to get rid of all those files. And again, I could just take video 6 here and copy it and rename it source, and that would be back where I started. But I'm just going to create now an empty source directory. Okay, so there's nothing in there now. And I want to create a couple files. There's going to be a main.c, a main.h. There's going to be a game.c and a game.h. And then I'm going to have a SDL init. And what's happening here is basically main is going to instance the game struct on the heap. And game has all the functions for game. But so it doesn't get too big since the initialization of SDL is quite large in itself. Even though that's kind of mentally part of game, it's a function that's dealing with game. I'm going to put it into its own file because so the size of the game file doesn't get so big. It's hard to see what's going on, and I know exactly where I'm looking for what I want to do. I'm just going to start creating these files. I'm just going to create all of them. So we need a main.h and a main.c, a game.c, and a game.h. And then we need this init SDL. So, and this is like initializing SDL is what this is doing. And we'll do an H as well for that. Okay, so these are all the files that we're going to be using in this video. I kind of want to set up main H first. So what I'm going to do, what my style in this is, since this is just a small, simple game, is all the globals or all the includes, I'm just going to put them in main H, and then I'm going to pull main H into every other header file. So main H is just a global, or it's just for the whole project, it's just holding everything that everything else needs. Because I'm not going to keep including like SDL2 in every single header file. I'm just going to include it once in main and then include main in every other header file. That's the idea, but there's different styles you can do. So right away, we're going to do the if and def. Okay, and then we do need to include SDL. So on my system, it's in the standard directory, which is going to be user include. And that should be where it is on all Unix systems, should be like that. Mac, since you're using brew, it's in a different place, but my makefile will handle this, should handle this for Mac. It might actually handle for Windows. I've put code in here, but I haven't yet tested it properly. But this does work on Mac and Linux. We're going to use this makefile. I'm going to talk about this makefile later in the final video, but this should it should be finding for you where everything is. The standard for me is SDL2, SDL.h. That is kind of like the Unix, or that is where SDL recommends it to be. So that some people argue that it should be like this, and this is the wrong answer, but you can do whatever you want as well. But this is the correct answer according to SDL. And this is the correct answer for my system. My system, it is an include already in the path, and it's in a subfolder called SDL2 because there's also SDL3 and SDL1. So they're in subfolders, and then that's where the header file is. I'm going to be using bool, so we do need to include that. And I'm going to be using IO for, printf and all that stuff. So So I want to define some constants, the window width, the window height that we're going to make, but we can come back to this later, probably when we get to it. So we can just have that be the main.h right now. So we want to include main.h, and then we're going to init main. And I'm not going to have any parameters here, so I'm just going to put void. If you don't put void here, depending on your compiler and what parameters you have, it might complain about that. If you just leave it empty, it won't like it on some of the stricter settings. What I'm going to do is I'm going to create a bool that is set to fail. It's set to exit failure. So if anything happens that my game hasn't succeeded, it's going to return the exit failure. So basically, I'm only going to have one path to success, and the default path is going to be failure. No matter how my game exits, it's always going to be considered failure unless the one path says, no, it did exit successfully. So my default here is going to be failure. So this allows me to bail out anyway. And as long as it's not successful, it's always error. So I'm setting the default to error here. So this is my exit status. I'm just making this up, but I'm going to call it exit. And this is a macro exit failure, which is like -1 or something. I'm not sure exactly what it's set to. So it's just a macro, the exit. So it's 1 or 0. I'm not doing that. So what I'm going to do here is put this return. Oops, why did I capitalize that? Okay. So basically, if I were to just run this, it would just say that the program errored. And what I'm going to make it is so if my program does get to its final running stage and runs and finishes running without anything going wrong, I'm going to change this to success. But otherwise, it's going to be failure. And now we have this thing where we need the game. So I'm going to switch over and start building the game up, because the rest of the code in here is going to be us instancing the game on the heap and then calling some functions on it. So we'll go the if and def game h game h and if. Now this one I'm going to include main.h. So this is going to give me access to everything that, the bool, the SDL2, stdio. It's going to give me access to all that stuff, so I don't need to re-include it. So main.h. My game struct is going to be quite simple. What we're going to be doing is we're going to be creating a SDL window and a render. So let's just look at these real quick. We'll come back to them, but later on here, we're going to be running this create SDL window, which is going to return a pointer to a window. And we will also be creating an SDL render, which is going to return a pointer to a render. I'm going to hold these in the game struct. That's where they're going to live. So we'll come back to those functions in a minute, but I'm just going to make a struct called game. And it's going to have this SDL window that is a point. I'm going to call it window, which is a pointer to an SDL window. And also a render. I'm writing it left to right, but you read it and see right to left, so it's confusing. So I don't want to read it while I'm writing it, because it's going to be, this is a window is a pointer to an SDL window, but I'm writing it SDL pointer window, so I don't want to say it while I'm writing it, because then I'm thinking backwards. Okay, so we have this game struct here. We're holding our window and our render, and that's going to be good enough for now. We have some functions dealing with this as well. I'm going to have a function that's a new function that's going to instance this on the heap and deal with it if it failed or not, and initialize anything that needs to be initialized. I'm going to have a game free function and a game run. And what I'm going to do here in every function in this project is I'm returning a bool. I'm always returning a bool or nothing. There might be an instance or two where this doesn't happen, but it's almost always a bool or void. And the bool is just telling me if this failed or not. So I'm not returning anything, pointers, anything from these functions. I'm always returning a bool because I want to know if it's failed or not. Whatever I'm doing inside of this function, I want to know if it failed. So if I need to return anything, I'm going to send it in as a parameter, not having it be the return. So this game new, I'm not returning a pointer to the game. I'm instead returning a bool. And I'm going to do this with everything because I'm going to use this to be able to collapse down all the functions that, all the stacked up functions, whatever I'm inside of. If it fails ever, it's going to be able to collapse all the way down and clean itself up and exit gracefully. And then also you will have that exit status on the way out. So this one, since I am returning a bool, but I want to create a game struct on the heap, what I'm going to do is I'm going to pass in a pointer to a game. And I'm going to be explicit always with my structs. I'm not going to, type def this. I'm just going to type the struct because I don't want to hide what I'm doing. I want to know what I'm doing. So this is going to be a pointer to a game. The reason why this is because I'm going to pass in a pointer and populate it. And since I'm actually affecting the pointer that I'm passing in, I need a pointer to a pointer. Most functions, I'm just going to have a pointer to a game, but specifically the new function and the free function are pointers to pointers because I'm actually affecting the pointer itself. So I also have a game free, which is going to do the same thing, pointer to pointer. And I am normally going to call this like struct game and just pointer G, not game. I'm just going to say G, like kind of like if you're programming Go, I like that. Except when it's a pointer to a pointer, I just write it the whole word so I know what I'm doing. I'm assuming you know a little bit of C, but basically what's happening here is this is just the pointer, right? But if I'm changing what the pointer's pointed to, that's fine. But if I'm changing the pointer itself, I actually need a pointer to that because I'm changing the actual pointer. So I'm not going to explain it. You can look it up and see. But if you're actually affecting the pointer itself, you need a pointer to a pointer. Okay, and for the game run, this is the way most functions are going to look. And this isn't returning anything. So this is a void. There's no failure on that one. So game run, there will be a failure. So I'm going to do this struct game and just pointer to G. This is kind of the normal way I do it. So this will be the normal looking thing. This is on the new and the free when I need to actually affect the pointer. This one, I'm not affecting the pointer. I'm affecting whatever is in it. So I have a pointer to the struct here. I can affect whatever's inside of it just fine. But if I actually want to instance this struct, if I want to pass in a pointer, create that pointer, and I'm not passing it back, I'm actually changing the one. So that's why it's a pointer to pointer. And I'm doing the same with this because if I have this as if I'm freeing it, I actually want to set that pointer to null as well. So I need a pointer to do that. Whereas this is just normal operations. Okay, so this is what our, if I could spell. Oh, I don't have the semicolon here. Okay, so this is our setup right here for game right now. And so in game, include game.h. So the game new was a bool. It's new, and it was this struct game. Game is a pointer to a game struct. Okay, so the reason why I'm doing this is because I'm going to be passing in the address of a pointer to game. And now right away, I am going to use calloc to create this. Now I'm not going to use malloc because malloc does not initialize data, But calloc does initialize it to 0, which I'm happy with everything being initialized to 0. So everything will either be a 0 or null pointer or however 0 is interpreted, which completely works for me. I like that. I don't want any garbage data or uninitialized data ever. So I never use malloc. So since I'm using calloc, we have this one more parameter, which is how many. And then we need the size of. And it's the size of struct game. Okay, so I kind of want to show what I'm doing here, but yeah, I am passing in a point. Yeah, so this is dereferencing it one time. So since I have this pointer to a pointer, I actually just need the pointer, not a pointer to a pointer. So I'm dereferencing it one time right here. So this is giving me a pointer to a game now, which is confusing in C the way that they use the star for both saying it's a pointer and for dereferencing the pointer. In Odin, they kind of fix this, but yeah, you have to deal with this in C. It's a bit confusing here. This is a pointer to a pointer game. This is dereferencing one of those. So we just have the pointer to a game. So this pointer that's being returned is stored here. Okay, now we need to check to see if it's not null. Because if it is null, something's gone horribly wrong. So if this is in fact, and we have to dereference game again, we have to keep dereferencing game over and over again, but I'm going to kind of set a dereference up anyway in a second here, so we can just use G. So if this is null, I could do a bang on this as well. I could do this, but for some reason when I'm doing the callocs, I just kind of do it more. I write it more explicitly. If you don't know what I mean, instead of this equals null, I could also do this. It's the same. It's their equivalent. This is just being a little more explicit. And what I want to do here is I want to print an error message, and then I want to return from this function false, because that's what I'm doing with all these bools. It's going to collapse down everything. So I'm going to use fprintf so I can get the formatted printf. And I'm going to tell this to send it to the standard error, not standard output, because this is not a normal message. This is an error message. And then I need to just make an error message, which is error in calloc new game. That'll do fine. New line character. I think I'm going to add a capital maybe on the calloc. Maybe here and here. I'm not sure. It's not in my notes that way, but who cares? So yeah, we got our error message that we're printing on standard error, and then I'm going to return. Now, if you've seen my yellow snow video, I did all the returns as positive because I was thinking about the way that I get return values back from SDL, and you check if something is non-zero, which would equate to true, it's returning badly. And so I went with that, but it is a bit confusing. So I'm going to use false here. And we'll just do a bang on all of these function calls to know if they've returned back. And we'll see that here in a second. So if you've seen my yellow snow in C, I'll probably re-record that at some point because I don't like the way I did it, but I was using true instead of false. But the logic here is going to be false. Okay. So now what I'm going to do is I'm going to dereference this. Well, I'm not going to use it yet. So what I'll show you what I'm going to do here, and I'll just comment it out. But I'm going to basically make a new pointer. A pointer, G is a pointer to a game struct, and I'm just going to dereference game. So I don't have to keep writing star game. I can just write G now over and over again. And I'm going to return true at the bottom of this function. So if I ever get to the bottom of the function, I know that this was successful. Since I'm not doing anything else here, I'm going to comment this out because I am going to add more to this later. But what I want to do is go to the next, because the problem is I need to initialize SDL and we haven't got there yet. So I'm going to come back to this function. So for game free, we have game free, and it's the same thing, struct. I'm reading it backwards. Game is a pointer to a game struct. Okay. And the first thing we want to do is know if game is not a null pointer. If game is a null pointer, I don't want to do anything here. I'm not trying to free a null pointer, and I can't deal with the members. If game is null, then I have no window member and I have no render member because game is null. So I can't do anything. So that's the first thing I'm going to do. If game. So I'm only going to do stuff if game is populated, if it's not null. So null is false or zero, so on and so forth. If it's anything other than false or zero, which is an address, it's going to be running this code. What I might do is the same thing up here that I've just done here. It could go either way. Like I could just go this star game over and over again, or right away I could do this. So I can just write G. Not much is going to happen here, but it will be more later. So I could say free G, and I can also say, or I could say free star, whatever. But G is the local one. So I actually want to set the original one that was passed in here to null. So I can say star game equals null. And I could do this here. It depends. This is only needed for simplicity. If I have, 30, 40 different things that I'm dealing with here. So I'll probably use this later. I'll probably just comment this out right now since I'm not doing anything with it. But basically, I'm going to send in the address to the pointer to a game. I'm going to free it and I'm going to set it to null. So outside of this function, that game is set to null after I freed it. So I don't have a dangling pointer. And I'm going to give myself a little print statement just to kind of like tell myself that, yes, this function did get called. I did get to the bottom of this. So like it did get freed. This is just kind of for me to visually see that my program is running the way I expect it to, because this is going to be calling other things to be freed, and I can have them print out their little message that it was freed as well. So I'm just going to do a little print to F here. And this is the main thing that gets freed. Game is the main thing. So I'm just going to put all clean. There will be other things, but they'll be called from here. So this is kind of the main thing. So we have that. We can't really go any further. What we need to do is we need to initialize SDL. So this is just kind of dealing with putting the game on the heap and cleaning it up. But there's going to be other stuff in here. We really need to initialize SDL. So basically, I'm separating some stuff that would be in game into its own file because I don't want it to grow too large. And then SDL.h. And what is going on here? So I'm going to include game. I'm not including main, I'm including game because this is really an extension of game. I'm still using the game. I need access to the game struct. And game will give me access to main anyway. So when I include game here, I'm still including main basically implicitly. But there is going to be one function here, and this is going to be game init SDL. And the same thing, it's going to return a bool. And this one's just going to be the G as a pointer to game struct. Okay, so I'm just going to yank this right here. In C, we're going to include that header file. So this one, it basically is a function that's just going to be dealing with initializing SDL. So that was our function signature. So this now is going to deal with bringing SDL online. So let's look at that. The very first thing we want to do is initialize SDL. It is taking a parameter, which is the flags. It is returning int. Int is 0 on success and something else, a negative on failure. This is why in the past thing I set the failure of functions to true and the success to false, which is counterintuitive, but falls in line with these things. But I'm not doing it in this video. So basically we're having 0 on success here and some negative number on failure. And then we have these flags. So these flags can be ORed together with a bitwise OR operation. So you can use multiple ones and you just use a single pipe in between them. So I can use this one, single pipe, another one, single pipe. But what has happened here is in SDL2, you would get memory leak messages if you initialized video, but only video. You had to initialize audio too, or you would get, I'm not sure if there were false positives or it was a bug, but now my system is using SDL3. The SDL2 package is based on SDL3, which is really goofy and it's unstable right now. It is not reporting any of its memory leaks now. It's hiding them from you. So you don't know what anything has done. So my notes say that I am using the video flag and the audio flag, even though I'm not using audio at all in this. You can also just use everything right here, which is what I might just use. But SDL2 on Arch Linux at the time of recording this is not stable and is in a kind of a weird broken state that may not be fixed or may be fixed. I'm not really sure. So we can't even check memory leaks right now because it either tells you're leaking everything or it tells you you're leaking nothing and it's lying to you and it's hiding it. So I think I'm going to use this one right here. But in my notes, I'm actually using video and audio ORed together, even though I have no audio in this game. And that was because of a bug in SDL2, but SDL3 is got its just huge amount of its own problems. And again, this is an SDL2 program that I'm using. It's just in their infinite wisdom, the SDL team in conjunction with Arch Linux replaced the SDL2 package with an SDL2 compatible package. And that SDL2 compatible package is based on SDL3. So I'm writing SDL2 code, but it's based on the package for 3 or something. And again, it's not working as expected. Okay, so anyway, so we have these flags here, and I'm gonna show you can OR them together, or you could use everything if you just want to bring everything online. So this is initializing SDL. To bring SDL offline, we can use SDL quit, and we need nothing put in, and it returns nothing. So we're only interested in these flags. The only thing I need for this one is really video, but you could do video and audio, or you could just do everything. And I'm going to put these in the main header file because I don't want to write them here because later on, I just want to hold them in their own constant, their own define. There is reasons for this. For one, they can just be in one spot. For two, the way that other ones get initialized, you need to check it multiple times and you would be writing all the flags in multiple places and it would be very messy. So I'm going to do a pan define. I'm going to call it SDL flags. And this is how you could OR them together. So you could go SDL init video. And the single pipe, this is a bitwise OR. And you can go SDL init audio. And what this says is bring them both on. It says bring this online and this. So it's kind of anding these together, but like in the English language, if I said I want a burger and fries, you're going to get both of them. So in the bitwise coding, you need to use the bitwise OR operator, and that is going to basically give me the bits turned on for this one and the bits turned on for this one. If I were to use the AND operator, it would not do that. So it's a bit weird. In English, it's kind of like saying AND, but in programming, you need the OR operator. And this is a bitwise OR, not a logical OR. This is the logical OR, 2 pipes. This is a bitwise OR, where it's actually taking the bits that make whatever this is. If under the hood, this is an int, probably. This is a UN32 under the hood, but it's just a bunch of bits. It's just ones and zeros. And this OR operator is saying, let's have all the ones. Whatever is a one on either one of them, we're going to have it turned on in the final. We could do this here like this, or we could just say everything without the parentheses here. And we could do this too, which is what I'll just do. And I'm also going to set window width and window height while I'm here, so I don't need to come back to it. And a window title. We're going to need these in a bit. So define, and I'm going to say window title. Conway's Game of Life. That'll work. And this will be window width. And I'm going to use 1280 by 720. This is just a number that looked good on my screen. You can use whatever numbers you want. We are going to mathematically be figuring out how many squares go in there and stuff. So you can choose which screen size you like the best. So this one's going to be 1280. And again, if you use different numbers than mine, it should not affect the program. It should still work. Okay, so I'm just kind of defining them because I'm already in this file, but the window title is going to be the string. Window width is going to be 1280 and height is going to be, these are just names I've chosen. They don't mean anything to SDL. I've just created these kind of constant names myself. Back into SDL right here, we have this SDL init. And it's always capital SDL on the SDL functions and just a capital I on the init. And we need these flags, and we've already set these flags up. So they were called SDL flags. That's what I called them. And remember, this is returning a 0 on success and something else, a non-zero or something on failure. So basically, if it returns anything, something's gone bad, anything other than 0. So I'm just going to put this in an if. So anything returned on this, something has gone wrong. And we can just grab this right here. I'm just going to yank this right here and use it. Because it's the same thing. I have one extra curly brace here. So I'm doing the same thing. I'm doing this fprintf standard error. I need to make myself a nice message, but we're also going to grab the error from SDL as well. So I'm going to say initializing SDL. SDL2. And I'm going to put a period on that. And then I'm going to get a string. So %s. And what I want to do is I want to get the error that occurred from SDL. You know, we have our own error message here, but I want the actual, what did happen with SDL? Why did it fail? So SDL has a way to get the error, and it's get error. It's SDL get error. So this is going to make a string that starts with the message that I put, or initializing SDL. And then I'm adding this other string in right here, and then a new line character. And that should be fine. So it's complaining down here because this is returning a something. If the end of this function is reached, then we're going to return true. because everything is good. Everything else is going to be returning something bad. So we are initializing SDL. I actually want to bring SDL offline. Sorry. So I'm going to bring it offline in the game, the free game right here. And it's just the SDL quit function, which is takes no parameters whatsoever. Down here. So we're bringing SDL online and we're bringing it offline. So before I go any further, I just want to implement this into the main because we have enough to fill out this main C now, so we can actually try the program and see it not doing anything, but hopefully not failing either. I need a pointer to a game struct. So what I'm going to do is I'm just going to create a pointer on the stack that's null. So this is just game is a pointer to game struct. We've seen this before, but it's just going to be equal to null. Okay. So this is just a null pointer on the stack in the main function. And what we're going to do is we're going to send this into we're going to send the address of this pointer into game new, and that's going to populate it for us. And we can use this if on it. If game new, if it was successful, we can do something else. So now remember, it's a pointer to a pointer. So I need to get the address of game, right? So that's going to go into the game function, and that's going to call calloc on it. And if it's successful, we get it's populated this now. So this game right here will be populated coming out of this if this is successful. If it fails, it may or may not be populated. It could have been populated, but some other bit of our function code later on could have failed. So that's why our game cleanup is checking first if the pointer is populated. Okay, so we're assuming this succeeded. If it failed, right away, we're just exiting with our exit failure. Do you see why I set exit failure as the default? If this fails, we just carry on. We don't need to do anything else. Basically, game was never created, nothing happened, we're out. So if it was successful, we can say game run. And we don't need a pointer to game struct anymore. We just need a pointer to game struct. So I can just put game in here directly. And if this is successful, we can just change our exit status. And I'm going to say exit success, which is just I think it's a macro or something like that. So it's complaining because it doesn't know what game is. We actually need to include game here. And since we've included game here, we don't actually need main anymore because game.h has main.h in it. And what I'm going to do here is no matter what happens with any of this, if this fails prematurely, it's exiting, right? If it doesn't fail prematurely, it's doing this. If this fails prematurely, then it's exiting, right? But if it continues on, then it's no matter what, I want to run the game free. Whether anything was successful or not successful, it doesn't matter. I'm going to, and I need to pass in the pointer to it because it's going to change the game pointer to null. So this is going to, this game is going to end up being null again after this free, no matter what was passed into it. If it's populated going in, it's going to come out as null. If it's null going in, it's just going to get ignored. No logic is either going to happen and it's just going to return. Because the first thing it does is check to see if this game pointer is populated. If it's not populated, we're just returning. And this is void. It's not checking the return on anything. So now it makes sense that we are passing in the pointer or the address to the pointer to the game. We're callocing it. If something's gone wrong, we're returning. We're using this bool as a return. If nothing goes wrong, this right here that was passed in has now been populated. It's no longer null because we passed in a pointer to game. Same thing here. The reason why we're passing in pointer to pointer is because we're actually setting, this is changing the one that's in main itself. This guy right here is set to null, but after this function, it's actually populated with an address if it's successful. After this function, it is back to null again. So if we were to print out what game is, it would be null here. It would be null here, not null, and then null again. And it doesn't really matter for here for main, but game is going to be instancing other things, and it's going to matter. Everything cleans itself up, basically. Okay, so we can actually compile this now and run this. We have enough. It's not going to do anything. It's not going to create a window or anything, but it's enough to just compile and exit. So we can say make, I'm just going to do a make clean because I had compiled something earlier. And I can change the make file. It doesn't matter, but there's a redundant F on it. Let's say make run. Okay, so we have some problem here. Undefined reference to game run. Unused parameter. And yeah, okay. But this is different. The other one was complaining about game. I haven't defined game yet. I'm looking at this saying, what am I doing wrong here? That we're calling the run function, and I haven't defined it. So this is bool game run. I'm just going to define it as nothing right now. G, that's the signature. And let's just cast G so it doesn't complain that it's not being used. And return true. I'm just putting this cast right here. Otherwise, it complains on my stricter mode. It says, hey, you're not even using G. Like, what are you doing? So this is basically using it for nothing. Like, I'm just casting it to void. That's just a workaround. Okay, there we go. So this is what I wanted to see. Basically, it's compiling it, it's running it, nothing's happening. Like what's happening is it's instancing a game on the heap. It's running the game run function, which does nothing, just returns, and then it's cleaning game up. So we do see that all clean happened. So this game free got a real pointer and did something and printed out game clean. So it is doing something. It's just not very exciting. I'm just going to run it again, and we should just see all clean. Yeah, there we go, all clean. So that's great. Let's just continue on. So what we need to do is we need a window. So we have SDL create window, which creates a window. We already have the pointer to the window in the game struct, but it's not popular. It's going to be null because we're using calloc. So we need a couple things here. This function is going to return a pointer to a window. We need a string, which they're calling title, and we've already set up a pound defined for a string that is Conway's Game of Life, so we'll use that string. We need an X, a Y, a width, and a height. So on our width and a height, we've already set up pound defines for window width, window height, so we're going to use those. The X and the Y is where this window is going to be positioned. And I'm going to use this macro here, this SDL window pause centered, where it's going to figure it out how to center it for me. I'm going to use that for both width and height. So this is going to be my pound defined of SDL title. And then this is going to be the SDL window pause center for X. Same thing for Y. And then for width, it's going to be my pound defined again, which is window width. And then again, my pound define window height. And then we have flags here. I'm not going to set anything here. I'm going to set it to 0. So 0 is just nothing right here, 0. Okay, you can OR these together if you're using multiple ones, but I'm not using any of these. So the same thing, you could put multiple with a single pipe between them as the bitwise OR, but for me, this is going to be 0. Okay, so we're going to use this, and this is going to be populating the window that we've already created a pointer to a window, an SDL window. So we're going to use that. So, and this is going to be in the initializing of SDL. And we have this G that we can deal with, right? We can populate stuff. So I'm going to use this. And we want to populate the window one. So I'll say G window, and it's going to be equal to SDL create window. And we need our title, and we've created one. So that is window title. We need our X and our Y, which are going to be the SDL window pause. Is it window pause or screen pause? SDL window pause centered. And the next two is the width and the height, which is, we've already created them. Window width, window height. And the last one is the flags, and I'm not using any flags. Okay, so maybe I've written something wrong here in the header file. I did. I put semicolons. Don't put semicolons on defines. I'm sure somebody was yelling at your screen. What are you doing? So that is what is kind of messing me up here. So I can remove this. I think. Do I have another one in there? What's happening here? Oh, I've spelled one wrong. Okay. Remember, game was callocked. So game was a null pointer for this window. This window member was a null pointer. Now we've populated it. If this function fails, it's going to return a null pointer. Returns, creates, or null pointer on failure. So if this function fails, we know it fails. It creates a null, it returns a null pointer. So all we do is check to see if the pointer is null or not to know if this failed. So we can just say if, we can say bang game window. If that has happened, we have a problem. And we can just grab an error message from here. And this one will be error creating window. I'll just say yeah. SDL window. Sure. And I'm still getting the message from SDL. So the get error. So that still works. And since we've done this, we need to go into game. So we have initialized SDL and we've taken it offline. Now what we could do, I can use this here. I'm just doing this for simplicity so I can deal with G instead of keep going this star game because, well, you'll see it here in a second. I'll show it to you the other way. But I want to make sure that this pointer is populated. I didn't actually do it in my notes. So we know that the game pointer is populated, which will be the G. We know that's good, but we don't know if the window pointer is populated. When we're calling this function, this game free, it could or could not be populated. We don't know. So technically you can put a null pointer into SDL to, well, let me show this function that we're going to use. SDL destroy window, it takes a pointer to a window and it destroys it. So you can, yeah, it is checking if it's null, but I'm going to check anyway. I don't want to put, because some functions may or may not allow you to do this. So I'm just going to do it the proper way where I'm just going to put my null check first. So we know game is a good value. It's not null, but we don't know if the window member is. So I'm just going to check it. But you don't technically have to do this, but I think it's a good idea. So basically, if this is populated, then we can go SDL destroy window on it. And this is going to be window. And then we're going to set it to null as well. Window. Okay, just so, and just again, this is just so that we know that there's not any mistakes being made. This can handle a null, but sometimes functions do or don't. You don't know what they're doing. Might as well just check to see if it's a null pointer first, and good practice to set it to null. Even though this is a cleanup function, these aren't going to be used again. I'm just always going to, anytime I'm freeing memory, I'm going to set that thing to null pointer. So now the question is why did I do this up here? It's because if I didn't, I have to do this, which is annoying. I have to put it in parentheses and do, I need to dereference it. And right? I need to do this every time. And I would need to do it here as well. Because I need to dereference this, because this is a pointer to a game struct. I need to dereference it one time so I have a pointer to a game struct. So I need to do this in parentheses and have the dereference of the game every time. So that is why I've done this right here. This allows me to just use G. So I'm going to just use G. So when I have a lot of things like that, I'm just going to kind of set that up like that. So this is the window. This is cleaning up the window. So we've populated the window in here. And if it fails, if this is a null pointer, it fails, this is going to return false. And then this isn't actually being called yet because we're going to call it in game right here. So I'm going to do the same thing here to simplify, not having to dereference game. And this is us calling the game init SDL function now. So if it fails, I want to return false. If it succeeds, everything is fine. So I'm checking the bang on this one because I'm checking the failure return on this one. If this thing succeeds, I don't care. I'm still going with my code. But if something wrong happened, I'm returning false. And this does need a G. So we could just pass the G into it. We don't have the dereference game. Okay, so this is us calling that right up here. I need to include, because I've kind of broken up this game stuff into two different, I need to include the init SDL.h. Okay, there we go. So yeah, so this function, let's go all the way to here. So if window fails, so let's say window fails, it returns false. So this function is returning false. This was called from game new. So game new, if this is failed, I'm only checking the failure, or we're returning false. So game new returns false. Well, game new is called from main. If game new is successful, it keeps going. If it's false, this if statement falls through, and we're doing game cleanup, and we're doing this. So game cleanup is going to take SDL offline. It's going to check to see if the pointer's populated. It's going to be populated, so it's going to, but window is not going to be populated. So let's look at the game cleanup in this specific instance right here. What's happened here is window has failed. So window is not populated. So it's going to say, hey, is game populated? Yes, it is. Okay, let's make a new G thing so we don't have to dereference it over and over again. Is window populated? It's not. It's just going to skip this. Window is still a null pointer. It's going to exit SDL. It's going to free the game on the heap. It's going to set game on the heap to null. And then it's going to print out this. And then this function is done here. And then so this function is done here. And now we're returning here. And exit status is still exit failure. Because the only time it ever gets changed to success is if game run finished successfully. Okay, so that's the kind of the logic of the whole setup here. Every function is returning a bool, and that's going to collapse all the way down. So back in here, so we have this window here, and we are cleaning up the window here in right here. If it's populated, that's great. What we also need is a renderer. We can't do anything yet with this window. This is going to create a window. Well, I can show it to you creating a window real quick. And to do that, I'm going to show you another function over here, which is SDL delay. So we can pause the program so you can see it. So SDL delay is dealing with milliseconds. It's going to take a uint32, an unsigned 32-bit integer in milliseconds. So if I wanted to delay for if I want the game to kind of pause for 5 seconds, I'll just put 5,000 milliseconds in here. So we're just going to use that. I kind of want to show the game running real quick. We are doing new. We are initializing. We have the window is already created with the initializing. So right down here in run, I'm going to say SDL delay. This is just to show you what the game looks like right now without our render. And I'm going to have it basically the game wait 5 seconds before it closes. And we should see a window, but the window's not going to look right. It's going to just be a border, but it's not drawn correctly. Let's see if this works. Okay, here it is. Here's our window. And see, it's not drawn correctly. This is because we don't have the renderer yet. So it created the edges of the window, the border of the window. Let's run it again. And it only stayed open for 5 seconds. And then it closes itself. See, what's inside of it's not drawn correctly. It's just took whatever was on the screen. That's because we haven't dealt with the render yet. Okay, so over here, we have create render. It's going to take a pointer to the window. It's going to take an index of the, what's the index again? The index of the render driver. We're going to use -1 on this. The index of the render driver to initialize the first supported one. We're going to use -1, so it initializes the first supported one. And then we have flags here. I am going to set this to accelerated. So I'm going to make my own, pound define again and call this render flags or something. And where are the render flags? Right here, I'm going to look at this. So we have software accelerated, preserving it. I'm going to do this one right here as a flag, just so it's using the accelerated. Though by default, I think it does anyway, but just to be sure, I'm going to do that. So I'm going to have the pointer to the window, -1 on the index. And this one is going to be, I'm going to make my own pound define render flags. And it's going to be render init accelerated. Was that what it was called? SDL render accelerated. Okay, so I'm going to make that first. And I'm going to put it here with the SDL flag. I'm just putting it here to make it more modular, I guess. And you could always change it or them here, everything else, and it's not. It's all in one spot. So this one is going to be SDL render accelerated, I think. What we're going to do is we're going to use that function right here the same way as we did here. And G already has a member called render that is null pointer right now. Because again, we did the calloc. So we'll say SDL create render. And this is taking the pointer to the window. We have a pointer to a window right here. So we can just say G window. Now we need the index is going to be -1. And now we need the flags, which we just created with the pound define. So this is going to be render flags. Okay. And we're going to check this render the exact same way. It's going to return a null if it's something's gone wrong. So we're doing the exact same check on it. So I'm going to grab this right here. And just change it to render. And the getting the SDL error message is the same. It's returning false, which is the same. So we've created this right here. And now the way we clean up after ourselves is this SDL destroy render. And this takes a pointer to a render and it just frees that memory. So this is just very much like the way that we dealt with the window. Okay, so if you kind of see I'm building up things here, this is this is initializing SDL. This is putting stuff on the heap. And then I'm in game free, I'm reversing it. So this was the first thing created, but it's the last thing coming out. This was the last thing created. It's the first thing. Now we have our last thing was the render. So this is going to be the same if render, and we're going to do SDL destroy render, and this will be G render, and then we'll set it to null pointer. Oh, these can be together. It doesn't matter. Okay, so I'm destroying the render. I'm destroying the window. I'm quitting SDL. All right, now we have a render, but it's still not going to do anything for us. If I were to run it right now, we would see the exact same thing happen that we saw before. See, got this exact same window happening. 5 seconds later, it closes because we need to clear the render and then we need to present it. So the render, when we clear it, it's going to clear it to the default render color, which is black, but we're still not going to see that. That's an internal buffer. But then we need to display that internal buffer. So it changes it to like the front buffer. So we need SDL render clear and SDL render present. We have SDL render clear. This takes a pointer to the render. It returns something. Although I'm going to be using this in the game loop, so I'm not going to check this. I don't check errors inside the game loop that are not important. In this one, if the render doesn't clear for 1 frame, I don't count that as important. So I'm not going to check the return from this at all. So this is just clearing the render. And then we have this one over here, which is going to present the render. So this takes a pointer to the render, it presents. This is void. And we've already seen this SDL delay. So since we've already seen it, it's already there in the code. So we have an SDL render clear and an SDL render present. So down here in run, we can get rid of this guy right now because we're going to use G. And we can say SDL render. And it's not renderer, it's render, which is weird because everything else is renderer. So it's render clear. And we need the pointer to the render, which is G render. And we're not checking error on that at all. And then we need to present it. Because if we just run the code again right now, we'll still see that same messed up window because we've cleared the render, but we can't see the render. We need to present it. It's like double buffered. It's like there's a back render and a front renderer. You draw to the back one. There's like a canvas that you're drawing to, and you don't want to see it while you're drawing to it, or it'll be like the very old game systems where you could actually see stuff being drawn on the screen and the last sprites that were drawn would be flickering because they weren't on the screen long enough. This one, it draws stuff that you can't see, and then when it's done drawing, it flips the buffers and you see the whole thing immediately. What's displayed to you is everything all at once. So that allows you to not have those kind of flickering like the old games used to have. So we have SDL present, which is flipping those buffers. So there is our render. Now that we have these, and this didn't need to be, this could be void because we are not checking anything yet. So I'm just going to change this to void since it will later on be not void. We will be checking something, but in this video we're not, so there's no reason. And I need to change it in the header. And then I also need to change main C because I have an if statement right here. So what we can do is just remove this if statement altogether and allow them to be together. Whoops. I need a semicolon here. Basically, this gets run. It can't fail. We're not checking failure. We will be in the next video, maybe. I'm not sure. We will be later, definitely. We have to rewrite this because of the if statement can't be there anymore because we're not returning a bool. Okay, so now when we open it, we should get a black window that's drawn correctly, and it's going to close after 5 seconds. And the reason why it's closing after 5 seconds is because, let's go here. Right now, our game loop, after it initializes first, which brings SDL online, populates window, populates render, and then we go run game. And run game, all it does is it clears the render, presents the render, and then it waits 5 seconds. After 5 seconds, the function is finished, and it basically is just freeing game. Game gets freed, and then it exits with the positive status. Nothing is checking inputs. Nothing is checking if I close the window or if I press escape. None of those events are being checked right now, so I actually cannot close the window. It's going to close after 5 seconds. And in the next video, we will be setting that up. I keep doing capital W. In the next video, we will set up closing the window properly. But we should get a proper black, yep. And again, it's going to close. I'm not going to click anything. It's going to close, yeah. So what happens if I try to close it? It's probably going to say it's not responding or something. It didn't close and it says not responding, but then it closes anyway. Because my operating system says, hey, you requested to close this, but it's not closing because my program isn't paying attention to that. It doesn't care that I pressed X. It's not dealing with that logic. We have to write that logic ourselves, and we will do that in the next video. So that was a lot. That's a lot of boilerplate. Basically, we are going to be doing this thing right here and this and all the parts. And there's only one more. I think there's just the board going on here in this project. What would it see? Oh, we have an FPS, we have a board, and we have a message. So each one of those things, the FPS, the board, and the message, each one of them is going to be doing the same thing where it controls its own calloc, it controls its own cleanup, but game is going to be calling the cleanup on all of them because game is going to be the one that holds all of those. This is like a composition. Game is going to be composed of all these different parts. So here we're handling render directly, but in the other ones, the message will be handling all of its own stuff. But from game, I'll tell message to clean itself up, and then inside of message, it's got its logic to clean itself up. Just to cover what we've done here, we have a function here that's initializing SDL. We bring it online. We have our own flags in main, which is everything, SDL, init, everything, but you can OR different flags together. We're including SDL. We're using bool. We're using standard IO. And these are just flags that we're creating ourselves, which is the SDL init flag, because you could put multiple here with the or you could change them, and it's always there in the program. The render flags as well, I'm just using SDL render accelerated. This is the string that we're going to use for the window title, and this is going to be used for the window width and height. We'll use it for other logic as well. So that's our header file. This is being pulled into every other header file. We have our game. We are including main H. Our game is just holding a window, a pointer to a window, a SDL window, and a pointer to a SDL render. And then we have our functions, which are new, free, and run. We also have a game init SDL function, but that's in a different file. These ones are pointer to pointers because we're actually affecting the pointer to game. And these ones we're just using it. So in here, we're including game, and then we have our own right here, this game init SDL. This is, again, could be part of the game C and game H. It's just I felt like pulling them out. So we are initializing SDL with those flags. If it errors, it's going to return something that's other than 0 if something goes wrong. So if it returns anything, this if statement gets kicked off. And we're using fprintf because we want to send this message to standard error. And this is a message we're preparing ourselves. And we're actually adding in the SDL error, internal error message to it. And we're returning false from this function. And that's if it fails. For the window, this game already has the null pointer to window, so we're populating it with the window create. We're using our predefined title, and then we're using the macros, the SDL window pause centered for X and Y. And then we're using our own width and height that we defined, and 0 for the flags for create window. That's populating the window. We're checking to see if it was populated. If not, we're error message. Again, returning false. Same thing with render. Render needs a pointer to a window. It has an index to the driver, I believe, which -1 just chooses the first available. And our render flags, which is going to be SDL render accelerated. That's the flag that we set up for that one. Same thing, we're checking to see if this actually was populated. Here's our error message, and we're getting the error message from SDL as well, and we're returning false. Otherwise, we will return true if we get down at the bottom of this. This is being called from game. So game new is all about, this is creating the space on the heap and returning a pointer to it. And we have to dereference game one time to populate this pointer. We're making sure it's not null. If it is null, then something's gone wrong. And here's our error message and we're returning from it. If not, we are kind of making a temporary G is a pointer to game, so we don't have to keep dereferencing this. And we're calling that function we just saw with G. And if this returns badly, we're returning, if this returns false, then we're going to carry on returning false from this function. Otherwise, we'll return true. If anything does, when it comes time for game free to be run, we first check if it's a valid pointer, if game is a valid pointer. If it is, we create a temporary, local G is a pointer to game, which is the dereferenced of, game, because game is a pointer to game. Since this is all a valid pointer at this point, we are seeing if the render member is a valid pointer. If it is, we're gonna free it and we're gonna set it to null. We're doing the same. If window is a valid pointer, we're gonna free it and set it to null. And then we're quitting SDL. We are freeing the actual pointer, the space on the heap for game. We're freeing that and we're setting that pointer to null. And we're just printing a message out for ourselves. Here, when game run gets run, we are just simply clearing the render with the pointer to render. We're presenting the render and we're waiting for 5 seconds. So in main, this new gets called. If that was successful, then it calls that game run that we just saw. That clears a render, presents a window, waits 5 seconds. Then our status gets changed to success. This if statement ends. Right here, cleanup gets run. It's checking if it's a valid pointer, and then if Windows is valid, it frees it and sets it to null. If render is valid, it frees it, sets it to null, and then it closes SDL or quits SDL. And then that's finished. And now we're returning from main function with a exit success. That's what this was set to, if it was all successful. Otherwise, if anything fails, which is only right here that can fail right now, it's going to exit with failure. And it's still going to attempt to clean itself up. Okay, so that's kind of everything. That one, it's kind of all boilerplate. So that is how to kind of set up the structure of any kind of SDL, simple SDL game that you want to do. So I hope you enjoyed that, and I hope it was educational to somebody. And have a nice day. I'll see you in the next one. Bye.